This next video will take you through the many functions that the skin has. Each of these is described on their own slides, so we're going to start with physical protection on the next slide. Think of the actual structure of the skin. That stratified, squamous epithelial tissue that makes up the epidermis. These are packed cells. Think of those dead packed cells that make up the stratum corneum. And remember, cells are constantly being pushed towards the surface as they divide from the stratum basale. So that creates a physical barrier very difficult for material such as pathogens or bacteria to pass through the skin unless there's some type of opening like a cut. So there are certain things that can pass through the skin, and they're listed right here, but for the most part, anything foreign would have a very difficult time getting through the physical barrier, which is the epidermis. There's also chemical barriers, which are protection for the skin. Think of sebum, which is oil and sweat that are on the surface of the skin. That creates a very hostile environment for bacteria and often kill it. And then we have UV protection from the melanin produced by the melanocytes in the epidermis. A third type of protection is biological barriers. And when we say biological, think of cells. And what kind of cells do we see in our skin that are a form of protection that we've seen before? Dendritic cells, which are the phagocytes in the epidermis that engulf foreign material. When you get into the dermis, we have something called macrophages, which are the phagocytes to ingest the foreign material. A large function of the skin is body temperature regulation. And we accomplish this a couple of ways. One way is through perspiration. Now you're going to perspire a certain amount a day regardless of your temperature. That's called insensible perspiration. But then you will perspire based on temperature, which is called sensible perspiration. And the method is if the temperature rises, well then you're going to have more perspiration, and if the temperature cools, you'll have less perspiration. One thing to note is that perspiration itself does not cool you down, but the perspiration evaporating from your skin into the air is what cools you down and pulls heat away from your body. If you're in a humid environment, well, that sweat doesn't evaporate off your skin because of the moisture in the air, and it doesn't cool you down because that sweat is not evaporating. In a dry environment, let's say a desert-like environment, it could be extremely hot, but your perspiration will dry very quickly, therefore more effective in cooling you down. Another thing we need to look at for body temperature regulation is the blood vessels in the dermis. Blood vessels in the dermis can dilate, and when they dilate, there's more blood near the surface of the skin, and that heat from the blood can radiate out to cool you down. When it's cold, well, those same blood vessels in the dermis will now constrict. That will bring the blood into the core of your body, which will preserve the heat. So just a summary, warm temperatures or hot temperatures, more perspiration, blood vessels dilate. Cold environment, less perspiration, blood vessels constrict. Another function is cutaneous sensations, which means your skin is a sensory organ. Think of the receptors that we went through earlier in this chapter, Meissner's corpuscles, tactile corpuscles, Ruffini corpuscles. All of those different receptors make your skin a sensory organ. There's some metabolic functions that occur in the skin. For example, vitamin D, or at least a precursor to vitamin D, is produced in the skin with sunlight. And vitamin D, of course, is what enables us to absorb calcium in our digestive system. Our blood could be stored in our skin. That's another function, especially when the blood vessels dilate in the dermis, up to 5% of our blood volume. And some nitrogenous wastes get excreted through the skin, also salt in the form of sweat.